Namaste. Today we'll discuss CBSE circles in precisely. We know the basic definition. The line segment joining center and any point of the circle is radius of the circle. If a line segment joining 2 points on the circle, it is called. Here AB is the chord. Line segment means line intersecting circle at 2 points. We'll call it as secant. If a line is intersecting the circle at only 1 point, it is called tangent. And circle first theorem we are having is the radius and tangent, they are perpendicular to each other. They both meet at A, no, that A is called point of contact. At the point of contact they are perpendicular, because if you take any other line segment, that will be more than this radius, so this is the shortest distance, so it is perpendicular to the tangent at the point of contact. Okay, here if they ask you, they can give two things and they can ask you to find the other thing, radius, and they give the lines, the length between center and the external point. Then you can find the tangent length. Here AP is the tangent length using Pythagoras formula. Okay, like that we can find two things they will give. They will ask you to find the other thing. And what our second theorem tells means, through external point we can draw two tangents, PA and PB. Length of the tangents drawn from external point are equal. Length of the tangents drawn from external point are equal. It can be, that is important theorem, they will ask in exam also. Okay, here PA and PB are the tangents, we have to prove them they are equal. Here see, you can tell this angle OAP is 90 degrees. Using our first theorem, radius is perpendicular to tangent at the point of contact. Similarly, here OBP is also 90 degrees. Radius is perpendicular to tangent at the point of contact. They both are right angle triangles. OAP and OBP both are right angle triangles. 90 degrees opposite side, here you are having OP. In that triangle also OP is there. So OP equal to OP, common hypotenuse, it is common hypotenuse. And OA length and OB length are equal. Radii of the circle. Therefore, these two triangles are congruent. See, triangle OAP is congruent to triangle OBP by RHS congruency criteria. Okay, if they are congruent, the other corresponding parts are equal, then PA length and PB length are also equal. This is what our second theorem. Using this theorem, you can prove any question in the circle chapters. Okay, once in they asked like this question also. PA and PB are the tangents drawn from external point. Prove that the line joining the external point and center of the circle bisect the angle between the two tangents. Same, up to here same. They are congruent, you have to prove by RHS. Now after proving that, the other corresponding parts are equal, so APO and BPO are equal. CPCT, same reason. Corresponding parts of congruent triangles are equal. That means here total angle is 60, means that here it will bisect, it will become 30. And one more important, I told several times, if 30 degrees opposite side R is there, means 90 degrees opposite side will be double than that. So here this will be twice radius. Okay, you can describe the other sides also. And more, if here one quadrilateral is there, see, OAPB, you can apply angle sum property. Sum of these two angles is 180, means sum of other two angles is also 180. Here 30 and 90, 60, 60. These two angles sum is also 180. One question they will ask in textbook. Okay, sum of these two angles, angle between the two tangents and angle at the center from the point of contacts. These two angles are supplementary. Based on the question, you have to give the answers. Okay, like that we can manage. And more, if they have given concentric circles problem, two circles with same center and different radii. They will ask us to find the chord length, chord for the larger circle, and tangent for smaller circle. Okay, here outer circle radius 5 and inner circle radius 3. They ask you to find the tangent length. Easily we can find. Here this is tangent means OP is radius, APB is a tangent for smaller circle. So here 90 degrees is formed. You can apply Pythagoras formula. And more, perpendicular drawn from the center will bisect the chord. These two lengths are also equal. If you apply Pythagoras formula, here you will get a square root of 5 square minus 3 square, that is 25 minus 9, that is root 16, that is 4. Here 4 means here also 4. So therefore chord length is 4 plus 4, 8 centimeters. Some more important questions I am going to discuss for you. I'll make that things simpler for you. What is the another important question means this question. If a quadrilateral circumscribes a circle, then what happens? What the surprise is going to happen? Then if quadrilateral circumscribes sum of one pair of opposite side AB and its opposite side DC, this sum will be equal to AD and its opposite side BC. Okay, here this is P, Q, it will, the circle touch the sides at P, Q, R, S respectively. Okay, how we will prove this? Using this, you just remember two steps here. If you remember these two steps, no, you can prove another question also. Same steps if you repeat. First step is we have to use second theorem, that is AP length is equals to AS length, because they are the tangents drawn from A. Next, BP and BQ are equal, tangents drawn from B. Okay, this side, try to get this side. CR and CQ, tangents drawn from C. And this DR length and DS length are equal, tangents drawn from D. Same reason, second theorem. You have to write the reason. Geometry chapters, we need to write the reason to get the full marks. Add them. If you add them, what you are going to get? AP plus BP plus CR plus DR is equals to AS plus BQ plus CQ plus DS. If you join AP and BP, these two segments, if you are going to join, you are going to get the side AB. Similarly, CR and DR, if you join, you are going to get the side DC. That side is AS and DS you join, you are going to get AD. BQ and CQ, you are going to get BC. This is what you have to prove. Sum of one pair of opposite sides is equals to sum of another pair of opposite sides. Clear? So using these two steps, you can prove the another question also. First two steps are same. If they given this ABCD is parallelogram, parallelogram circumscribes a circle, then it will become rhombus. How means up first two steps are same. You can prove in another way also. This is the, anyway you learned this question. Up to here you'll do first two steps. If you do, you'll get this. In parallelogram, you know opposite sides are equal. AB length and CD length are equal. BC opposite side, AD lengths also equal. So instead of opposite side DC, you can write AB. Here also instead of AD, you can write BC. AB plus AB 2AB, BC plus BC 2BC. So in parallelogram, only opposite sides are equal. Now you have proved that adjacent sides are equal. All sides equal means it will become rhombus. If ABCD is parallelogram circumscribes a circle, then it will become rhombus. Hence, ABCD is rhombus. Like that we can prove. Some more important questions we'll discuss. This is an example problem. They asked several times in the board exams. TP and TQ are the tangents drawn from external point T. Then this angle and one more thing I missed. Here, this result you can remember and you can use anywhere else. Once they in bits they asked, they gave the lengths of three sides and they asked you to find the other length. What they gave, no? AB length they gave 12. AB length they gave 12. AB is where? Here the AB length is they gave 12. And BC they gave you, wait a second, 15. CD length 14. They asked you to find AD length. They told that it circumscribes a circle. Any quadrilateral if circumscribes circle, no? Then sum of one pair of opposite sides is equal to sum of another pair of opposite sides. This result you can use. 12 and you have to add the opposite side 14 and BC they give 15. These two sum how much it is? 26. That plus 15 if you bring this side, 26 minus 15, so 11. So another side is 11. Like that, three sides are given means you can find the fourth side. See, you can use this result to solve the bits. And now we'll come back to the example problem. Here theta means they asked you PTQ is twice OPQ. This you have to prove 2 theta. That is an example problem, but I tell you a simpler way to solve that. How I will make it simple? No? By taking the references. I can erase this side. First, that OPQ, I'll take it as an angle theta. Okay. Then, next, this OPT is 90 degrees. Why it is 90 degrees means this radius is perpendicular to tangent at the point of contact C. So, total sum is 90. Here theta means the other angle will be 90 minus theta, simple. So angle TPQ you will get 90 minus theta. Now TP and TQ are the tangents drawn from external point. Then TQP is also 90 minus theta. Why? Because TP and TQ are the tangents drawn from external point T. Length of the tangents drawn from external point T are equal. In this triangle, these two sides are equal. Means then the angle opposite to equal sides are equal. No, there 90 minus theta means here 90 minus theta. Now finally, you apply the angle sum property in TPQ. Sum of the angles in any triangle is 180 degrees. So this side 90 plus 90, 180, 180, 180 will get cancelled. Minus theta, minus 2 theta. If it goes that side, then PTQ is equals to 2 theta. That theta is nothing but that angle OPQ. You have proved or not? Here 2 theta came or not? If once exam, they asked here 15 degrees is given. There find sine 2 theta they asked. Here 15 degrees means there what you will get, that you tell me. There you will get angle will be double. So here theta you will get as here 15, there it will become double, that is 30 degrees. You have to remember this example problem and you have to keep it as a result in your mind. Here 15 means there it will be doubled, that is 30 degrees. Now they ask you to find sine 2 theta. Sine 60. So it is root 3 upon 2. Like that they will ask us. Another question beyond the textbook they can ask is this question. Okay, there PA and PB are the tangents drawn from external point. They will give tangent length and they will ask you to find the perimeter of that what there one triangle is formed. See, one more tangent CD, it is intersecting circle at E. There one triangle is formed. That triangle perimeter they will ask. That is also been asked several times. So we'll do that for you. So you just remember here theta means here 2 theta. Right? Next, one more exam point of view important question I am doing for you is this. Here given AP length is 10. To find, they asked you to find perimeter of PCD. This diagram. See, for anything, first we have to use circle theorems. Tangents drawn from external point you use just. PA and PB are equal, they are tangents drawn from P. Similarly, CA and CE are equal. Okay. Next, D and DB are also equal. All the same reason, length of the tangents drawn from external point are equal. Okay. Next, see if you want to find the perimeter, how you can find? You have to add all the sides, no? That is, PC is one side, CD is another side, and PD is another side. CD, these two segments, if you join, no, you will get the CD length. So PC plus CE plus ED plus PD. Okay, what you can do here? C you can replace with ACC or CA, and DE you can replace with DB because they are tangents drawn from D. Now, if you join PC and AC segments, what you are going to get? You only see. You are going to get PA length. There, here PD and DB, if you join, you are going to get PB length. Okay. Now, PA and PB are equal. Instead of PB, you can write PA. PA plus PA means twice PA. Therefore, perimeter, what you got? Twice PA you got. PA length they gave. So, that triangle perimeter is twice the tangent length. See, 2 into 10. So, 20 centimeters. Okay. This result they can ask you directly, or they will give some value and they ask you to find the perimeter. Okay. Like this, we have to understand and do. Thanks for watching. All the best.